We're going to do example 2 for parametric speed. So you're given the system x of t is 1 over t and y of t is t cubed minus 6t squared plus 1 for t values greater than 0. What is the speed of the particle when its vertical acceleration is 0? So the first thing here is that this is a two-tiered question, right? I need to know the formula for speed, right? So I need to know the formula for the speed of a particle. So the formula for the speed of a particle, that speed, right, we learned in the last couple videos, is going to be the square root of my x prime of t, quantity squared, plus my y prime of t, quantity squared. So what that part of the problem means is that I'm going to have to find x prime of t and y prime of t. So let's go ahead and find those. So my x prime of t, because this x of t is a t to the negative first, will be negative 1 t to the negative second, or negative 1 over t squared, which is probably the easiest option. My y prime of t is just going to be some simple power rules, right? So I'll drop the 3 down and get 3t to the second minus a 12t, and then the plus 1 is gone. Cool. And then the other part of this problem, right, so now that I have those functions, the other part of this problem is that I'm asked for the speed at a specific time. So I'm asked when its vertical acceleration is 0. So in order to find the time, I need to find when its vertical acceleration, which would be y double prime of t, is 0. So since I already found y prime, I can go ahead and find my y double prime from that pretty easily. It's going to be a 6t minus 12. I want when this vertical acceleration is 0, so I want when 6t minus 12 is 0. I'm pretty sure I get t is 2, right? So 2 is my t. So what I'm being asked to do is plug in t is 2 into these equations and write the square root. So if I want to go ahead and find x prime of 2, right, I'm going to get that that's a negative 1 over 2 squared, which is 4, right? And if I want to go ahead and find y prime of 2, that's going to be a 3 times 4 minus a 12 times 2, right? So that's going to end up being a 12 minus a 24, or a negative 12, right? So I'm going to have my x prime of 2 and my y prime of 2. So then now what I need to do is I need to plug these numbers, right? This guy in here and this guy in here. So I'm going to erase and give myself a little bit of space. We should probably be able to erase the top. Right, so what's going to happen is I'm going to get that my answer should be that the speed when t equals 2 is the square root of a 1/16, because that's what I get if I square the negative 1/4, plus a 1/44, which is what I get if I square the 12. So we're probably going to be asked to clean this up a little bit. It's not super fun, but it is what it is, right? So I made up these numbers, and that's probably why we're getting these nice, big, obnoxious numbers here. So I'd probably be expected, like, this is a correct answer, right? But the general assumption is that the AP is probably not going to give you numbers this big, but if they did, they'd probably want you to get a common denominator with the 1/16, right? So if I were to do that, I would recognize that this 144 is actually over 1, and I'd times by a 16 over 16. I don't really feel like doing 144 times 16, but I will, because here we are. The easiest way to do 144 times 16 is probably to recognize that this is a 12 times a 12 and a 4 times a 4. So I'm going to recognize that this is actually a 48 quantity squared, right? Because it's 12 times 4 times 12 times 4. I'm probably just going to do this as a 50 minus 2 and FOIL out 50 minus 2 times 50 minus 2, right? So 50 times 50 should be a 25 with 2 zeros. Outer is a minus 100. Inner is another minus 100, and last would be a plus 4. So I think that I get 2304. So as ugly as that is, I think the other possible answer I would get is a 2305, because the 2304 plus the 1 all over 16 in that square root, or square root of 2305 all over a 4 that's not in the square root, because the 16 could have been square rooted. Again, I totally made up these numbers, so don't be taken aback by the fact that you got such a huge number. There's a good chance that if this really was on an AP, they would either take this answer, because that's fine, or they might even just take an answer like, as silly as it is, 1 plus whatever 144 times 16 is all over 16 inside that root. Right, oh, sorry, can't see that. So again, the goal here is not usually for the AP to make you multiply huge numbers, but it just happens that I made up these numbers and they were largish.